Hi guys, so this tutorial is about acceleration, a vocabulary word that's going to come up throughout our unit and that you really need to master right now. So you might already have an idea what this word means in your head. Most people, when they hear the word acceleration, they think of things speeding up, and that is one way to accelerate, to move faster. But there's two other ways you need to be aware of. It's true that you can accelerate by speeding up, but it's also called acceleration if you slow down. In everyday language, you might have heard the term decelerate, which is okay, you can say that, but scientists refer to slowing down usually as negative acceleration. That's just because scientists like to be more precise in the way that they describe things. Technically, both speeding up and slowing down are forms of accelerating. So is changing direction. So even if, let's say, even if I am going at the same speed continuously, let's say I'm this guy here in yellow, if I make a sudden turn to the right, even though I maintain the same speed, technically I'm accelerating. So there's three different ways that you can accelerate. You can speed up, you can slow down, or you can change direction. Two special cases of speeding up and slowing down that you want to be aware of are stopping and starting. When you come to a stop, you have maximized your slowing down. When you start, you are beginning motion, and that's a form of speeding up, because before that, you were going zero. In order to understand acceleration, you have to understand what we mean when we say the word speed. If I were going to measure how fast each of these runners is going, I might say that this guy in the front, let's say, is traveling at a speed of 8 meters per second. I probably should have picked a better pen to do that in. And then maybe the guy over here, just right to his left, is only going 7 meters per second. And maybe this guy's only going 5 meters per second, right? Those are speeds. That's how quickly they're moving. Acceleration is a measure of how much your speed is changing. So how much speed is changing for every moment that you're moving. What does this look like? So how do we measure acceleration, and what units do we want to use? So for speed, I said that we could use units meters per second, but there are other units of speed, like on this speedometer, we've got miles per hour, which is what the English unit system uses. Or you could use a metric unit like kilometers per hour, which is also shown on this speedometer, and that's so they can sell the cars both here and in Canada, and also in Europe. So what does acceleration look like on a speedometer? Well, your speedometer will tell you how fast you're going at any particular point in time, and it'll also show whether you're speeding up or slowing down, because if you're speeding up, this dial here will move this way, and if you're slowing down, the dial will move back the other way. How quickly it does that is a measure of how much acceleration you have. If it takes you 1 second to go from 0 miles per hour to 30 miles per hour, if that dial moves from here to here in 1 second, then you would say that you're accelerating at a rate of 30 miles per hour. That's how you do per in math, you put a slash. So you're accelerating at 30 miles per hour per second. If you maintain that, that would mean in the next second you'd pick up another 30 miles per hour of speed, and you'd now be going 60 miles per hour after 2 seconds. At this rate, after about 5 seconds, you'll be going so fast that you'll probably break the sound barrier, right? You're going to be picking up 30 miles per hour of speed every second you're traveling. Wow, you're really accelerating. You could also do this in reverse. You could be losing 30 miles per hour of speed every second if you were hitting the brake. And we would call that a negative acceleration, and we would write it like this. 30, that was my computer making that horrible noise. It scared the heck out of me. That's why I made this little boo-boo here. 30 miles per hour per second of a slowdown would look like that, negative 30 miles per hour per second. So the units of acceleration are a little bit bulky, right? It's like 2 slashes and lots of different units all mushed together. This can get really confusing. But luckily in our science class, we're going to measure speeds in meters per second, not miles. It's also abbreviated with an M, just like miles. And so speeds will be written as meters per second, And accelerations will be in meters per second, which will abbreviate to meters per second squared. So these are going to be the units of acceleration. Let's look at that in an example using gravity. During the fair test experiment, we dropped stuff to see how quickly it would fall compared to other stuff. Let's say we take one of our balls up to a cliff and we drop it, and we put a little tiny speedometer on the ball so that it measures how fast that ball is going every second it's in the air. It would be picking up speed the whole way. It would be almost like somebody was driving that ball, putting their foot down on the gas pedal. But instead, it would just be gravity pulling that ball the whole way. So in the first second that an object falls, before it starts falling actually, it obviously has zero speed, right? It hasn't started to move yet, so it's not accelerating. But after 1 second of falling, if you could look at the little speedometer on your ball, it would read approximately 9.8 meters per second. So that's how fast it would be going. It would be going about 9.8 meters per second. But it wouldn't stay like that. In the next second that it was falling, if you glanced at your speedometer again, that would have doubled. And then it'll triple, and quadruple, and quintuple. So that after 5 seconds of falling, that ball will have picked up enough speed to be traveling at 50 meters per second. Each second, it picked up the same amount of speed. And that amount of speed is known as the acceleration due to gravity. It's an actual number. It's 9.8 meters per second per second. For every second that an object is falling towards the Earth, its speed is increasing approximately 9.8 meters per second. But we don't like writing it like that. Instead, we do 9.8 meters per second squared. So you need to know this number. It's a constant here on Earth. That number, though, discounts air resistance. And since there's always air around, it's not a really true number. This is how fast things would pick up speed if there weren't any air pushing back up against them, and obviously there is. But in a perfectly airless world, everything would fall towards the ground at exactly this speed. It would increase its speed by 9.8 meters per second every second that it's falling. Okay, see you guys in class.